Okay, we're picking up yesterday's lesson on, which was vectors day 4, on the scalar dot product. This little formula is critical. We're going to just rearrange this formula later, so you've got to have this formula down. If you haven't already got this in your notes, you should seriously write it, because just staring at it means you're probably not going to actually memorize it. And this is important that you not think this is multiply. There is multiply involved in it, but that does not mean A times B. It is a special thing called a dot product. All right? So if I have two vectors and I find their dot product, if they come out to 0, this dot product here, if the dot is 0, then, this is dumb, but it might work for you, they're perp. If it's 0, they're perpendicular. If the dot product is 0, they're perpendicular. Could you see in honors pre-calc how we might rearrange that and say, here's two vectors. What number do we need to change to make them perpendicular? And then you got to go backwards and say, okay, well, what was that deal again? Perpendicular meant that they had a dot product of 0, so then I got to set these equations equal, the dot products equal to 0. All right, so let's just do a dot product. So let's say we had, actually, let's find one here. That's all general. I want to find a specific one. Okay, here's a specific one where we got vector A and vector B. I'd write them in column form and then find their dot product, which is, again, the 3 times the -2 plus, anyway, I'm going to see if you remember from yesterday how to find the dot product of those two. Pausing for a second while you do that. If you are lost, at a minimum, write this as a column vector. Write this as a column vector. Put them right next to each other. And I'll show you how to get the dot product from there. (3, -1, 5, -2, 4, -1. And the dot product you multiply across. 3 times the -2 makes, I'm going to do this in the dot product area, -6 plus -1 times the 4 makes -4 plus 5 times -1 makes -5. Put it all together and I get -15. Did you guys get -15 for the dot product? All right. Since that didn't come out to 0, that tells me something. It tells me that those two are not perpendicular vectors. Okay, so if I make a couple of vectors with these rulers that I have here, you won't be able to see that on the screen. But okay, so I have, let's say it's like this and this. Do you get that I already know, since the dot product isn't 0, that these are not making a right angle like this? See, this would be a right angle. They're not doing that. That's all I know for sure. I don't know exactly which way they are. It could be all kinds of different crazy ways, but they aren't making it perpendicular. All right, so next, let's find magnitude of A. That's this guy's magnitude. Do you remember how it was A squared plus B squared plus C squared? And then you take the square root of all that? All right, I'm going to pause for a second and give you a partner to work with. Hopefully you got square root of 35 for this first one. Anybody verify square root of 35? All right, good. Now you know you're doing it right. Now find the magnitude of the other one. Square root of 4 squared, 2 squared, etc. I'm going to pause for a second. Okay, so we got 16 and 4 makes 21. 1 squared is 1. Did you get 21 for that one? Cool. Now let's put it all together. This is the same formula as you saw before, but those magnitudes have been moved to the right side. Why'd they do that? Because we have the dot product, and we have the magnitude, and we have the other magnitude. We have all of that, so we put all of that on that one side, and it'll just make a nice little decimal. Then, how do you fix this so you get theta alone? You undo cosine by doing what? Inverse cosine, and that'll tell you your angle. Go ahead, put all those things in. The dot product was negative 15. The angle here and the magnitude and the magnitude get multiplied. Divide, you got a decimal. All right, I'm going to pause for a second while you give that a try. Again, you do inverse cosine and you have the angle between the two vectors. All right, so this, putting in my dot product divided by the two magnitudes should give me that. And now I have to solve it and get theta all alone. At the end, you do inverse cosine of that, and I would recommend giving an answer in radians. If you gave the answer in degrees, it's not like it's automatically wrong. Just look in directions. Usually they're going to say answer in radians. Okay? And I think it's 2-ish radians. I don't know. Yes? What did you get for your final answer in radians? Raise your hand, please. How many groups have it? A lot of groups have it. What did you guys get? 2.16. Can anybody verify 2.16? All right. Now, 2.16 radians. Is that a big angle? A small angle? How many degrees are in a radian? About 60. Smidge less. Okay, it's like 58-ish. All right. So this is like 120 plus a little bit more, maybe 125 degree angle between those two. Now remember, this is another thing that's weird about vectors. I'm putting them together to show you this angle. But do you get that these are the same vectors as I move them apart from each other? I can still say it's the angle between those vectors, even though I just moved them. Because when you move them, as long as you keep them going in the same direction and the same length, they are the same. You move them together, you can see the angle. But these vectors might be out in space here, not touching each other, and they can still have an angle between them. You can move them as long as you keep them moving in the same direction and same length. You can move them together, and then you'd have the angle between them. Okay, so that's how to find the angle between two vectors. Now, we've now covered about a third of the stuff that's on the test. Remember, your test isn't next week. I'll be gone all next week. I got a sub coming in, Mr. Winterhalter. He has taught this stuff before. He's a math teacher from many years. He retired, and anyway, he's the perfect guy to have for a sub because he can probably answer all the strange things that can come up. So, then you're not going to test at the end of next week because I thought some of you might be like, this is a new teaching style and I need to have one more day of review. So I'm making one more day of review when I come back, and then we'll take the test. Okay, but I can't, if you don't pay attention next week, you can't figure you're going to fix 5 days worth of vectors on one day that I come back. That's not realistic. Stay with him. Do your homework. Try. Ask him questions. He's a math teacher. He can help you. But then I will give you that one extra day of review when I come back. And that'll also have a morning time. Remember, on Monday mornings, you can get extra help. I'll be here. So if you feel really lost, you can come in the morning on Monday morning. And then we'll do Monday of review. And then, Monday's actually Memorial. So it's Tuesday I'm thinking of. Now, normally, on Tuesdays, I'm not available. But because I will have been gone, I will cancel other meetings and things, and I will make myself available on Tuesday morning when I come back. If you want to come in for extra help, I'll be here. Okay, so these two vectors, I could very easily see this kind of question coming up on the test. They are vectors, except there's something in here that's changeable. Look at what's changeable. M. M is a variable. There's normally not M's in there. There's I's, J's, and K's. So those are all normal. There's an M thrown in. So if I was going to write this as a vector, I would not write the I, the J, and the K, but I would write the M. 5M, negative M, and negative 3. And then this one, M, 7, and 2. Now, their dot product, now they didn't say this. They said they have to be perpendicular. But by saying that, do you get what they're really saying? that the dot product equals 0. You should do one of these, just in case that's the kind that we are tested on. Go ahead, take these, do their dot product, and if they're perpendicular, the dot product will be 0. Figure out what m has to be. It's a parabola. By now, you should have solved quadratics a million times, and I shouldn't have to tell you how to solve a quadratic, but I'll remind you, if you can factor it, once you set it equal to 0, if you can factor it, you should. And if you can't factor it, what solves all quadratics? Even ones with imaginary answers. Quadratic formula. All right, I'll pause for a second while you figure this one out. Okay. Dot products go multiply like this across here, and I got 5m squared. And then I add the next one, negative 7m. And then I add the next one, which is plus negative 6. Plus minus just means minus. Then, if that equals 0, which is what we want, which is really nice because then it's all ready to be factored. If it can be factored, you should. Did anybody actually find it? Was there a way to factor this one? What'd you get? 5m plus 3 and 2, sorry. Okay, 5m, I missed that one. I'm going to try again. What were they again? 5m? Plus 3 and? Minus 2. Awesome. Thank you. And then, hey, I can factored it, and so therefore I can get the answers this way. If you didn't notice that, I totally won't blame you. I wouldn't blame you for looking at that going, I don't know what that factors to. You can always use quadratic formula and get the same answers. You should have got 2 as one of your answers. That one's really obvious. This thing is going to equal 0. And then this one would be 5m plus 3 equals 0, so 5m equals negative 3, so m equals negative 3/5. Okay, so there's an answer. There's an answer. Now, I hope you've been doing this long enough to realize there's a chance that one of these is impossible, like wouldn't work when you actually put it in. But at a minimum, if I put in the 2, that's the easy one. You just check and make sure it really works. Do you get it's supposed to give me a dot product of 0? So if my grade depended on it, I just check and make sure that they actually gave me a dot product of 0 then. All right. Okay. What's the other option for dot products that might be a big deal besides things that are perpendicular to each other? What do you think could be another big deal? Yes? Parallel. All right, so what if you have 2 that are parallel? What would the angle between them be? Could you have an angle between them if they're parallel? No. All right, so if you came up with no solution, that could be a reason. All right, moving on. Let's get to this right here. This has got a nice little 2 little mini vectors. They're not 3-dimensional even. And I'd like you to sketch what they look like. Do you remember finding that little hat thing from yesterday? That was the unit vector. That was where you took the magnitude of the vector and you did 1 over that in front of it. I'm just going to review yesterday a lot here to make sure you really get this part down, because this is like half the test-ish, third to half. If I can get you solid on that, then next week, the other half the test happens with Mr. Winterhalter. And that'll let him start from scratch with the new smartboard. If I try to teach you some of that, then you might be saying, well, Mr. Server said this other thing. So I'm going to let him teach the new topic totally starting on Monday. So we're just mostly reviewing yesterday and finding the angles between things with that little formula. One other thing I should tell you is that in the past there has been this big hoo-ha lab at the end of the year. And I'm sure some of you probably won't cry over this, but I'm not going to be able to fit in that lab. And it's going to relieve some stress on you and me because of the fact that I'm gone for a week right when the lab was supposed to happen. It'd be too much to ask the sub to try to figure out how this lab works. It involves bowling balls and ramps, and some of the ramps are like bent, so you have to tip the ramp a certain way to compensate for the bent ramp, and then otherwise the bowling balls won't hit, and it's just so many things that could go wrong. It's just not worth it. So it's just the same stuff that we would normally do on the test, except you actually set up your bowling ball on the ramp and actually roll it, and hopefully they hit. So if you want to feel any better about missing that lab, there are so many things in the real world that are off that usually the kids have to actually figure out the right answer and then tweak it based on trying it 3 times. And by the 3rd time, they usually get them to hit. But do you get bowling balls slow down slowly over time? We can't compensate for that in our vectors. I mean, we could if we did really complicated ones. There's also, do you think that the floor in the commons is exactly flat? No. All it takes is for there to be a tiny little dip in the floor, and now the bowling ball moves. And then it doesn't hit where it's supposed to hit. So anyway, it's not perfect anyways. But the vectors kind of get you close, and then from there you can tweak it. So anyway, we're not going to be doing that lab, which will save you and me a whole bunch of pain during next week. So, all right. Just in case you had forgotten how to do this, for this I need the magnitude. The magnitude was square root of 25 plus 9, which makes square root of 34. And then I put that in front of, over the square root of 34, in front of the 5, negative 3. Now, could you actually multiply it out? Yes. And if you did, just get, it's not like super hard. It'd just be 5 over root 34 and negative 3 over root 34. All right. Now, I found the unit vector for A. You figure out the unit vector for B. It's a lot like the other one. Sometimes the problem will say, hey, now that you found a unit vector, scale it up to be 100 feet long. Well, you just times it by 100. And usually that goes on top because 100 over 1 would force the 100 up on the top. And there we go. Now it's 100 feet long. So that's a different kind of question. This time it's find the unit vectors and then tell the angle between the unit vectors. So you've taken these vectors that might have been like 3 feet long. You shrunk them down to 1 foot long each. And then you're finding the angle between them with that little formula. Who's got a good short-term memory and has it without looking? What was that formula that we just did a second ago? Do you remember it? A dot B, yep, and that's asterisk because you're right, it's not just multiply, it's dot product. And that's actually just multiplied. All right, good. You've got a good short-term memory. That's one you need to know for the test. You need to memorize that one. It is a derivation of the original formula which I gave you, which had this. Do you get, they just multiplied or divided both sides by that, and now those aren't in front anymore. They're over there. So that you can get this to all be one big decimal. All right, this is going to be icky. You're going to need a calculator. It's going to have a lot of chances to screw up on, you know, like the square root of 34, or what if you don't do it in the right order as you're putting this in. Get your answers. They're nasty decimals. Find the dot product. Then divide by the magnitude times the magnitude. And then at the end, you got to do inverse cosine. All said and done, see if you can get the right answer. There's so many chances to mess up in here. Be really careful. Take one little step at a time. When things are tricky like that, just do one little step, write it down. Then do another little step, write it down. All right, before we proceed to that, let's make sure you have this B one done correctly. Did you have a magnitude of the square root of 5? So 1 over root 5 times negative 2, 1. That made the unit vector. Now find the angle between the unit vectors. Pausing while you give that a shot. So, they got a decimal for this. Then they did inverse cosine, and the kids got the answer. 3.06, and what is that? That's radians. If I was going to take a look at it, I'd be expecting a really big angle. Isn't that almost 3.14? And if it was 3.14 radians, what would that mean? That would be pi radians, which would mean what? That the angle between the two was, what? Pretty much a straight angle, which would mean what? They're parallel, but at the same time, like if they were parallel, couldn't you just move them? And put them end to end like this? Okay, so what I said earlier was not correct, and I was thinking it through. If they're parallel, I was saying you couldn't have an angle between them, but you could kind of, if you kind of fudge it a little bit, by moving the tip to tail thing, or the two tails together, you could look at it as a 180 degree angle, also known as a straight angle, in case you didn't know that terminology. And the angle between them is pi radians. All right, so let's get to this one. This is part of the test. It's a small part of the test, but let's see if you can tackle. We're not going to do all of these, but if I was going to do the first one here with you, AB, I'm going to draw it here, plus BC, obviously, I hope obviously, that gives you AD. Right? With me on that? Am I doing something wrong? Did I do that right? Oh, I didn't do that right. I read it wrong. My bad. Dang, I was wondering why so many people were looking at me kind of funny. Okay. A to B, and then it was BC. I was looking at I mixed two problems together. My bad. And B to C. That one comes out a C. Okay, sorry. And they should have little vector symbols above them. Would you try, with your partner, some of these trickier ones? Like, see if you can figure out what E comes out to, and H. Try those two. I'll leave that one up there as an example of one. Okay, let's see if you put this together. CD is this one. And remember, think of them as arrows that you can move around. Remember, if I move this up here, that's totally okay. It's the same. If it's here, it's here. It's over here, it's the same thing. Vectors can move like that as long as they got the same direction, same magnitude, they're the same. So then, what's BA? Here's BA. And now, can I move these to add them together? I would just go like this, tip to tail, and boom, they're back to the zero vector. But that wasn't an add question, was it? It was a subtract. So you had to kind of do a double reverse thing. Say, okay, well, I want to subtract it, which means I'm adding, but I'm adding it going the opposite direction. So then I got to reverse this thing. And I don't know if I have a reverse function, so I'm just going to go like that. There. Now it's reversed. Got rid of this one. It's reversed now. And now if I add them, it's like that. How the heck are you supposed to say that? Did anybody figure that out? I know you're like, oh, there's no letter at the end, but you can do it. There you go, 2CD. It's this except doubled, right? So 2CD. Very good. Okay, on the other one, we'll get started anyway and see how far you are. AB, that's this. I'm going to make it red and change colors. Plus BD, that's this one. I better not use blue or I won't be able to see it. I'll use green. And that'd be simple if it was stopped right there. But then it's minus CD. Well, I'm going to put in CD as another color. Maybe I will do blue, but I'll go off the page. Let's see, you can see it better. There. If I was adding it, it would be simple. I'd be at a C, but I'm not adding it. I'm scratching it. So then I got to reverse this, right? So I'm going to reverse that and draw it this way instead. And then I can add that on there. And you can't see the tip arrow tip, so I'll just kind of cheat and move it like that a little bit. Yes? Uh-oh. The reverse of CD is the... Oh, it was CD! Oops. It was CD in the first place. I assumed DC, but it wasn't. It was CD. So now I have to reverse it, and that'll bring it back to this. Ay. Hold on. Undo. Stop. Thank you for catching that. I was backwards. I saw CD and just assumed DC. All right, so then it's back to reversed, and now it is that way, and so then it is just AC. Oh, these have lots of double reverses in them, so tricky. Okay, so that's a review of that type of problem, and now we are ready for assignment day 4. I already had you do part of this, right? And in fact, I need to put something else in the grade book, so we got to grade that last night's homework. It was about as easy as it ever gets. If you didn't do it, sorry. I gotta get some more in the grade book. So take out last night's homework, which is right here. And now, keep it out on your iPad. Slide your rows back to where they're supposed to be. And then we're going to move in a direction with magnitude. Okay, while we're grading, the video doesn't need to happen. So for the assignment for tonight, we are just going to simply do the rest of the problems that are in this section. It was a pretty big one, and therefore, and if you guys remind me at the end of the hour, I'll try to post a better quality answer key. Did the answer key have work shown, or was it just this thing at the end? Was there one that was posted with work shown? Oh, good, then you've got one. Awesome. Because sometimes they only have this as the answer key, and those are tough to learn from. So, okay, anyway, so the assignment is to do the rest of this section for tonight. All right, now get up, move to the spot behind you. People in the back, walk up to the front. Leave your iPad where it is. If it's fine, you can put it away if you want to, but somebody's going to come and sit where you are. All right, and that's the end of the video for today. We just finished up Vectors Day 4, and Mr. Winterhalter will come back and teach you the next few.